Good morning, everyone. I'd like to welcome everyone to Long's seventh installment of the Long Coffee Break series. My name is Jordan Weiss. I'm a sales engineer here at Long. Today, we'll be going over gas detection and refrigerant monitor layout. Mike Lee with Specified Controls is here with me. He's going to go over some of the products and services Long is offering to hopefully make y'all's jobs a little bit easier. This time, I'm going to turn it over to Mike to go over the product.
Thank you so much, Jordan. As Jordan said, my name is Mike Lee. I'm with Specified Controls. We're a manufacturer out of Indianapolis, Indiana. We've been working with Long for several years. And today we're going to hit on some gas detection information and refrigerant monitor products. So Jordan's going to bring up a couple slides here and we're going to get started. So first and foremost, let's talk about application and let's talk about where we're going to see gas detection most likely. So parking structures, warehouses, car dealerships, anything that deals with cars or trucks inside a building is going to be the most common gas detection need we're going to have. Municipal buildings, bus barns, fire stations, salt truck storage and workshops. Grow houses, a very big industry now that requires a lot of gas detection. But really the key to gas detection is anywhere that oxygen can be displaced inside of a building is a real concern. And just a couple quick things. When we're dealing with vehicles, we're never looking at CO2, we're looking at CO, carbon monoxide versus carbon dioxide. And then the other thing is when we're dealing with cars, when we're charging vehicles or we're charging electric motors of any kind, hydrogen is generated. So just keep that in mind as well. So moving forward from there, let's talk about code requirements. ASHRAE has a whole plethora of information. All of it basically says what's there on the screen in red. If there's vehicles involved, if it's a parking garage or vehicles at all, you should probably use gas detection if it's an enclosed structure. So just keep in mind that there are various codes, lots of different choices. In terms of code, we're going to talk a little bit about some of the agencies in a second, but code is very, very different throughout the states. So in Colorado, it's different than it is next door. So just keep that in mind. Now let's talk about the most common gases we're going to look at, which is CO, carbon monoxide, and NO2, which is nitrogen dioxide. So carbon monoxide generated by a unleaded fuel burning engine, and it's obviously dangerous. We all know that. When we're dealing with cars, but anytime we're burning a cleaner fuel, it's going to create carbon monoxide. And when we're using diesel, that's when we're going to have nitrogen dioxide or NO2. So what I want to point out here is the difference, and it's very important both engineers and contractors understand that we measure every gas at a different level dependent upon its toxicity. So the key to take away from this slide right here is we start experiencing as people, as humans, we start experiencing problems at the level of 200 parts per million of CO. That's where we start to see a real problem for ourselves. But when we get to nitrogen dioxide, when we talk about NO2, look at that chart. We start seeing the same type of things, mild headache, tiredness, irritation at 1 part per million. Very vast difference. So the truth is we measure nitrogen dioxide in parts per billion, and we measure we didn't measure carbon monoxide at parts per million at 200, where we really start to get worried. So just keep in mind every gas is different, and we have to plan for that differently as far as sensors and systems go. So I mentioned we're going to talk about agencies. Various agencies throughout the government have different rules and different standards for gas levels that are acceptable. So as you see here, NIOSH, they're going to tell us that the low level alarm when we should start to begin mechanical ventilation is 35 parts per million of CO. And these are all about carbon monoxide. But they're going to tell us that the high level is 200. That's where we really need to make sure that all mechanical ventilation is running and we are getting fresh air in the building. But then you look at the EPA, and the EPA says that it must be under 9 parts per million as an average over an 8-hour period for a working environment. That's what the EPA says. And the EPA says at 35 parts per million, we should be alarming and bringing on mechanical ventilation. But then you go to OSHA, And OSHA, completely different. OSHA says 50 parts per million, 4 to 8 hour period as an average. So it's very important that you figure out which standard that you're going to be held to, and that is all dependent upon which type of building you're dealing with. Are you in manufacturing? Is it an office building? What are we doing with that building? What's the use of that building? That will also help us dictate which one we're looking at in terms of the standards that we need to meet. But it's important to also understand they're all different. They all come up with different rules and different statements on this. The most important thing to remember is toxic fumes, explosive fumes are a concern, and you need to make sure that you are ventilating properly and providing a safe breathing environment for the occupants. So from there, let's talk about some design ideas or design suggestions. And we're going to be very simple and basic with this. And that is that the gas detection side of things is when we're designing a system, when we need mechanical ventilation, let's make that clear, when it's mechanical ventilation is needed, you should be using exhaust fans, outdoor air supply fans, makeup air units, or louvers and dampers. You should not be using, from a design standpoint, a standard rooftop unit that is not made to bring in 100% outside air. The reason for that is standard rooftop, if you bring in 100% outside air, you're going to avoid the warranty. You're going to, crack the heat exchanger. You're going to rust out the coil right away. It's not made to do that. On top of the fact that service techs, when they come to work on that piece of equipment, have no idea that that is part of your gas detection safety system, and they're going to start cutting wires, and we're not going to have a system after that happens as well. So strongly suggest when you are designing a system that you design it as you would a smoke evac system. People die and people get sick in a smoke situation, in a fire situation. They don't die because they inhaled smoke. They die because they inhaled the fumes in the smoke. And keep that in mind when you're designing a gas detection system as well. We got to get fresh air in there. That's the most important thing. Okay, as far as sensors go, let's talk about sensor layout and how sensors function. So first thing I'll tell you about sensors is virtually every manufacturer out there who makes gas detection products has the same sensor technology from the standpoint of the same sniffer, the same element that detects the gas. GE makes most of it. It's almost all the same in terms of that. Now the electronics are different, and the way that the sensor functions and what it can do is different. The actual element itself is usually the same. And so what I tell you from that, or what I want you to take from that, is almost all gas detection sensors are going to have the same radius or coverage area. And that is about 50 feet. 45 to 50 feet is going to be the coverage area. Okay. And so the big thing to take away from that is that we can cover 7,200 square feet on an open air pillar in a parking structure or in a warehouse, as an example. If we got one pillar coming down, we put a sensor on it, we can cover, excuse me, a radius of 7,200 square feet. But if I put that sensor on a wall, on an actual solid wall, I'm not covering 7,200 square feet anymore. I'm covering half of that, or about 3,600 square feet. So keep that in mind, and you can see to the right of your screen there, those pink circles. That's just an example of a parking structure where the sensors are mounted on pillars. So there is full coverage, 360-degree coverage around that pillar. If they were on the wall, I would not have full 360-degree coverage. And that's true of every gas detection company out there. It doesn't matter if it's ours or someone else's. And then sensor height, just a very important thing to point out there. It's always a question. The sensors themselves, it all depends on the gas. We are here, and Long is there to help you with that determination and that piece to it. So as far as our products go, Specified Controls offers 55 different gases or fumes that we can sense with our systems. We have every type of sensor you need, from explosion proof, NEMA 4, simple NEMA 1s, duct mount, wall mount, all that fun stuff. We've got all those, and we have combination sensors as well that would allow us to do CO and NO2 or CO and methane. So we have all those, but the other thing, and the most important thing to point out, is our panels. And they are scalable, and they're fantastic. They allow us to do a lot of different things that many other companies can't. And so just keep in mind that we're here to, and Long is here to help you with selection of those products. So moving on from there, let's get to refrigerant monitors because we want to be mindful of the time. The refrigerant monitor that we offer is a little bit different than you're used to. The traditional model for refrigerant monitor is to have a pump inside of an enclosure, and then it's outside the room, and it cycles through every, it cycles air every 5 seconds, and you're testing and sampling air, and there's a lot of maintenance, and the pumps go bad, and it's just not the best setup. What we have done with our partners is create a refrigerant monitor that's electromechanical. The sensor that you see on the screen there mounts directly in the chiller room or directly in the area where we want to sense refrigerant, and then it wires back to our panel outside the room. So now we're meeting UL requirements. We're meeting the need of having a sensor in the space and then having a display outside the room that will allow us to meet those requirements. And then the last thing here is you see at the bottom of your screen all of the different refrigerants that we can monitor with our system. And you'll see there that all the legacies, all the older refrigerants are there, all the current refrigerants are there, and to my knowledge, almost every future refrigerant is there that you're going to be seeing or coming into contact with, from the new Carrier stuff to the new Daikin stuff. So we can pretty much, to our understanding, cover every refrigerant that you're going to come in contact with this great product. So call your Long guys; they'll be able to help you with that as well. But let's talk about the most important part, or the biggest difference that our product has against all the other manufacturers, and that is this: we are in a situation where we can provide custom layouts, as you see on the screen there. We will lay out where your sensor should go from a suggestion standpoint. We will also provide you custom wiring diagrams for the job. You can see that on the screen as well. We will actually look at the job and we will engineer it for the contractor. We will actually provide a full control submittal, just like you're used to seeing with a DDC system. We will pre-program the panel and the controls, and the sensors for the contractor, so it's plug and play when it arrives. And that is a very important piece. Saves hundreds of dollars and many, many hours of time and labor when we pre-program those panels. And then the last thing is the guys at Long will be happy to come out and do startup for you, for your customer or for your contractor. And it just works out really well. We're providing these great services to make the system better and easier for the contractor and ultimately for the engineer as well. So please reach out to your Long sales associate, your Long sales engineer. They will be happy to help you, provide selection, provide opportunity for you to get the help that you need. So Jordan, I'll give it back to you, but that's the long and short of gas detection.
Thanks, Mike. I just had a couple quick questions I just kind of wanted to go on. I think everybody's kind of wondering. I just wanted to know about scalability of you guys' products. You mentioned that a little bit ago. And just if you could touch on that, about how the coverage of the products in small jobs to large jobs.
Sure. So, so Jordan, the first part of your question about scalability is that we can, because of our panels, and if you click for me, Jordan, first things first is we can do sensor wise. Our sensors can be standalone, so they can actually control an individual fan, or they can control, two sensors can control one fan, and we don't need a panel. So we've got relays, we've got outputs in that sensor that could actually even modulate an EC motor on a fan. So we've got a lot of options there as far as simple and basic control, but then we move into the panels, and the panels are really where the scalability comes in. So most of the other manufacturers out there have one panel or maybe two panels that are very large, and they're designed to cover every job. So you have an expensive panel. Well, with our option, you have a simple small panel. This is a 4-sensor panel you're seeing on the screen. So this is perfect for that small garage, that fire station, the little application where you've got like a Jiffy Lube, like a place you get your oil changed, things like that. Very small, but only 4 sensors. And you can imagine a 4-sensor panel versus a 120-something sensor panel. This is much more cost effective. The next option you're going to show there, Jordan, is our standard panel, which is used almost all the time. And this panel is a 32 sensor panel and covers almost every gas detection job there ever was, with few exceptions. So this, again, very scalable, lets us control costs very effectively, and it's simple. It's very, very simple, especially when the manufacturer pre-programs it for them. Last thing is, here's the big panel. Here's the big one that competes with all the other guys out there that have those big, expensive panels. What I'll tell you about this panel is it's great, it's fantastic, but rarely needed. And so the important thing to remember with this panel is this is the panel that is Backnet if the panel needs to be Backnet. But I just want to reiterate on Backnet that you need to call in and talk to your Long sales engineer because they can help you with that piece, because the Backnet side of it is a little bit confusing when it comes to gas detection. And we have multiple options that would allow you to provide Backnet. It's just we need to look at the job, we need to look at the application and decide what's the best way and most cost effective. Last little point I want to make, all the products you see there, it's all daisy chain wiring. It's very simple and very easy. You daisy chain for power, you daisy chain for communication, and it's simple and easy. So again, scalability, big factor in what we do. So guys, I think that'll do it. Jordan, thanks so much for the time.
I think we'll wrap it up here. I want to thank everybody for joining us today, and please join us next week when Leroy Willow will go over VRV integration with the cloud. So look forward to it. Thanks for everybody for showing up. Appreciate it. Have a great day.